Okay, so can I move this down? Yeah. All right. So after after Ernest Rutherford discovers the nucleus, he himself wins a Nobel Prize. In 1908. Okay. He predicted that there was another particle that was yet to be discovered that had no charge in the atom, and he was right. About 20 years later, James Chadwick discovers the neutron, just as Rutherford had predicted would occur. Okay, so we have 3 subatomic particles, at least 3 that we talk about in this class: protons, neutrons, and electrons. Protons are going to have a positive 1 charge. Relatively speaking, the mass of a proton is 1 atomic mass unit. You will never be using the absolute mass. The proton is located inside the nucleus. We can use the number of protons to identify the type of atom that we have because the number of protons will never change. Let's take a look at the next page. We've also got neutrons and electrons. The neutron has no charge. It has a relative mass of 1 atomic mass unit. It is inside the nucleus. The electron is a negative 1 charge. Its mass is so close to 0 that we say it's 0 atomic mass units. And the electron is outside the nucleus. The rest of this chapter focuses on electrons. Okay. And then we need to go over atomic number and mass number. You may want to have your periodic table out that has all the atomic masses on it because it actually labels the atomic number and the mass number for you, so that way you never get confused. So let's take a look here. And this should be reviewed. This should be something that you guys discussed in biology at the very beginning of the class. So the atomic number is given a variable of z. This is the same as the number of protons and the positive charge in the nucleus, okay? If you have a neutral atom, the number of protons will equal the number of electrons. I'll show you how to identify if something is neutral or not. Now, if I add up the protons and the neutrons, I will get the mass number. So the mass number is given a variable abbreviation of A. This is the sum of the protons and the neutrons in the nucleus. The atomic number you may obtain from the periodic table. Or you may be given a number of protons, and then you can deduce what the atomic number is from there, because it would be the same thing. But be super careful with the mass number. The mass number does not come from the periodic table. You can't look at the periodic table and round the fractional numbers or the decimals that are under the symbol. You cannot round them to the nearest whole number. A teacher might have taught you how to do that in middle school, but it is wrong. Does that make sense? And I'll show you what that looks like. There are 2 different notations when writing the symbols with the mass numbers and the atomic numbers. This is called an atomic notation. So this is known as atomic notation number 1. Where you have the symbol of an element X, the mass number in the upper left-hand corner, and the atomic number in the lower left corner. They will often omit the atomic number and expect you to know that you can look at the periodic table to get it, okay? The other version that you will see is the symbol with the dash and then the mass number after it. So this would be atomic notation number 2. They often write things this way when we're talking about isotopes, but you'll see it written both ways, okay? Then, lastly, if I want you to calculate the number of neutrons, the number of neutrons will come from the mass number minus the atomic number. Okay, so we're going to take a look at the top of the next page, and then we're going to do some practice. We're almost done with this section. Okay. Okay, let's take a look here. So actually, before I do this, on this previous page at the bottom, down here, they gave you some neutral atoms. So here is one, and here is another. When there is no charge in the upper right-hand corner, it is neutral. So for instance, here on this example, this 7 is my atomic number. That tells me I have 7 protons and 7 electrons because it is neutral. If I want to calculate the number of neutrons, take the mass number, which is 14, minus the atomic number, which is 7, and that's how you get 7 neutrons. Okay? Let's take a look at the top of the next page. At the top of the next page, they give us some ions. You know they're ions because they have charges in the upper right-hand corner, okay? The anion has a negative charge, the cation has a positive charge. So let's look at the cation here. We have an atomic number of 12, so that means I have 12 protons. The protons do not match the number of electrons because I have a charge. When there is a positive charge, that means you lost that many electrons. So the +2 means I lost 2 electrons, so you would take the atomic number minus the charge, and that would be 10 electrons. Okay? If I want the number of neutrons, you would take the mass number 24 minus the atomic number 12, and we have 12 neutrons. If I'm looking at an anion, anions have gained electrons because they have that negative charge, and electrons are negatively charged, so I take that on. So here, this -3 really means I gained 3 electrons. So this 15 is supposed to be over here. I don't know why it's in the wrong place. So here we've got 15 protons, because that's the atomic number. And then the atomic number plus the charge, which is 3, gives me 18 electrons. And then the mass number minus the atomic number is going to tell me how many neutrons I have, which is 16. Are we cool so far? Yeah? Okay, let's do some practice then. So if you take a look at the bottom of this page, they've given us a few practice problems. So I want you to do number 1, and then let me do number 2 with you because this one we haven't done yet. And then you guys can fill in the table for number 3. This says write the atomic notation for neutral atoms of the following. That means write the other atomic notation. So that means you would write the symbol. This number is the mass number. So you would put that in the upper left-hand corner. And then you would have to look at your periodic table to get the atomic number for bromine. Your periodic table tells you at the top that the atomic number is in the upper left-hand corner. Do you see that? Okay, so the 35 is your atomic number, and you would put it here. And these are all neutral in number 2. Okay? All right, so you guys finish these, and I'm actually going to have you guys fill this in. So let me bring this up a little bit. Okay, so you guys can do, let me finish writing this. What did we say bromine is? 35. Okay, there we go. All right, so let's have you guys do number 1, okay? And then let's have you guys do number 2, and then you do number 3 first row. And then I've got the second row for number 3 in the back. And then over here, you guys do the third row for number 3, okay? Okay. First row, you guys ready? I want to read it across.
42.
Okay.
95.
Okay.
We're not done with the protons, but we have the other ones.
Atomic number is the same thing as the number of protons.
Okay, so 42.
Okay.
Question 3.
And you got 42 for this?
Yeah.
Because there's no charge? Okay. Okay. Moving on. Second row. You guys ready? What'd you get for the atomic number? Okay. How about the number of neutrons?
35.
What symbol did you get here?
C.
Okay. So your mass number's here, atomic number's here, and then what did you get for the charge on it?
-2.
Yeah. And this is because you had gained 2 electrons, right? Okay. And then for the last, this third row, what'd you guys get for the number of protons? And then the number of neutrons. Perfect. What'd you get for the symbol here? AG. Okay. Do you have a charge on it? Yeah, +1, and this is because you lost 1 electron. Perfect. Any questions on that? I have one last topic to talk about. Okay, so when you're ready, turn the page. We're going to go to mass spectrometry. You're going to need a calculator eventually.